This is section 7.5 on parametric equations on the class notes. Let x equal f of t and y equal g of t, where f and g are two functions whose common domain is some interval I. The collection of points defined by x, y is equal to f of t, g of t, and this is called a plane curve. So in our previous examples, we looked at problems that are functions. So you have y as a function of x, or x as a function of y, or we could have thetas, but we're going to be looking at x as a function of t. So x is equal to f of t and y is equal to g of t, where t is in the interval. I represents the interval, and these are called parametric equations of the curve. The variable t is called a parameter. So I have drawn out an example of a parametric curve. The arrows show the direction or orientation along the curve as t varies from a to b. So here is t is equal to a, and this has the point of f of a, g of a. So this would be equivalent to the x coordinate, and this right here is the y coordinate. And then at the ending, you have t is equal to b, so then your x coordinate is f of b, and your y coordinate is g of b. So somewhere along this curve, you're going to have a general x coordinate of f of t and g coordinate or y coordinate of g of t. Here's our first example. Discuss the curve defined by the parametric equations, then graph these on the calculator. Convert the parametric equations to rectangular equations, and then you want to put at least 3 arrows on the graph. Okay, so I'm going to show you the whole solution, and then I'll go through each parts of those. Okay, so we're going to start by graphing this. So you're going to have 1, 2, 3, 4 columns. And on the first column, you're going to label it as t, so that is the parameter. And then you'll have x, and then y, and then I'm just going to combine your x, y coordinate. Okay, so this right here, which represents the parameter, is -2 is less than or equal to t is less than or equal to 2. And then the parametric equations are x is equal to 3t squared and y is equal to 2t. So since you're starting at a -2 and going out to 2, I'm just going to put the whole numbers in starting from a -2 on the t column. So I start with a -2, and then I have a -1, 0, 1, and 2. And then I'm going to substitute in the t value into this x equation. So x is equal to 3t squared. So when you put in a -2 to t, you get a 12 for the x value. When you put in a -1 for t, you get 3. 0 is 0, 1 is 3, and then 2 is 12. And then you put in the t values in for the y. So y is equal to 2t. So when you put in a -2 into t, you get a -4. -1 in for t gives you a -2. 0 is going to be 0. 1 is 2. And 2 is 4. All right, so this last column, I'm just writing it as a point. So it's 12, -4, 3, -2, 0, 0, 3, 2, and 12, 4. All right, so now I'm going to plot this. So when I'm graphing it, I still have it as the x-axis here, and this right here is the y-axis. But I got the values for x and y by using the t values that I've set up. So for my first point, I have, and when I drew out the axis, I could see that the x value, the largest number is 12 and the smallest is 0. And so I just concentrated on the positive x values. And then for the y values, I'm going from -4 to 4. So I have it going from -4 to 4 along the y. All right, so I plot these 1, 2, 3, 4, 5 points. So 12, -4 will be right here. And then 3, -2 is right here. 0, 0 is right here. At 3, 2, and then at 12, 4. All right, now notice here that you have points and not arrows. And so since it's starting at a -2, I'm going to start at this point, and then to show the direction of it, I'm putting arrows. So here's the arrow going this way, and then I have another one, and then it's going through this way, a third one, and a fourth one. So you should try to put at least 3 arrows to show the direction of the graph. Okay, the next thing that you want to do is you want to convert the parametric equation to rectangular equation. And so I look at these two equations and I need to get rid of the t's. So I'm going to use substitution. So I look at x is equal to 3t squared and y is equal to 2t. And I can see that it's easiest to solve for t in this equation. Right? So I write out y is equal to 2t and then solve for t, so y is equal to, or t is equal to y over 2. And then I put in the t is equal to y over 2 back into the x, and so that gives me x is equal to 3t squared. So x is equal to 3, and in place of the t, I'm going to put in y over 2 quantity squared. And then if I simplify that, it's y, or x equals 3/4 y squared. So this is your rectangular equation that is equivalent to the parametric equation. Okay, we're going to try now the second example. So for the second example, I'm given x is equal to the square root of 2t and y is equal to 4t, and my parameter is t is greater than or equal to 0. So I set up my truth table in the same way. I have my first column as t, second column is x, and my third column is y, and then I have x comma y. Right, now for this one, since it's starting at 0 and then it's going infinitely into the right direction, I'm just going to choose about 3 or 4 points. Right, so that will be enough to give me an idea about how the graph looks. So I'll choose 0, 1, 2, and 3. So some of the values are not going to come out nicely, but you could just estimate the values. So when t is equal to 0, we get x values of 0, and then 1 is going to be a square root of 2. 2 is going to be 2, so I'm just placing it back in here. And then 3 is going to be the square root of 6. All right, for the y, I get 0, 4, 8, and 12. And so then I write out my ordered pair here. So I get 0, 0, square root of 2, 4, 2, 8, square root of 6, 12. And then I'm going to plot that. All right, so I have square root of 2 is about a 1.4 and square root of 6 is about a 1.5. So I'm putting in my coordinates, so it's at 0, 0 here, and then the square root of 2, 4, that's going to be this point here. 2, 8 is right about here, and then the square root of 6 is going to be, oh, I think it's a 2.5, not a 1.5. So it's going to be square root of 6, and then 12 is going to be up here. Okay, so that would be my graph. And so it's going to start here, and then the arrow is going to go this way here. And then at the very end, since it's going out to infinity, I'm going to put a last arrow at the very end. Okay, now to solve for the rectangular equation, I'm going to solve for t in the y. So y is equal to 4t. So then solving for t, I get y over 4. And then placing it back into the t for the x, that gives me x is equal to the square root of 2 times y over 4. So I get x is equal to the square root of y over 2. Now the other way that you could do it is to take your x is equal to the square root of 2t, and then I'm going to square both sides. So that gives me x squared is equal to 2t. And then I solve for t, which gives me x squared over 2. And then in place of the t and y, I'm going to put in x squared over 2. So you get y is equal to 4 quantity x squared over 2. And so when you simplify that, you get y is equal to 2x squared. Now we know this is a upward parabola, and on the parametric equation you only have the right side. So you'll actually have to give it a domain restriction and say that x is greater than or equal to 0. Right? So there are many representations of the same graph, and so this parametric can be represented in many ways depending on how you solve the problem.